Okay, college algebra, you are here today. Your teacher is not. So we need to cover section 4.5. I know it's a short class. We should be able to get through the material. And then you'll have homework on 3.5. And then the next time I see you, we can look at the homework for 3.5 and then we'll be reviewing for our quiz. Okay? So the next period I see will be a block period. So if we have questions over this, we can go over this, but we also need to be looking at the review of 4.6. Okay, so transformations. We did this earlier in Unit 3. What does it mean to reflect x squared about the x-axis? Well, that would be if I graphed negative x squared. That's an indication that that graph has been reflected about the x-axis. What would indicate that it had a vertical shift? So x squared, plus 7. That means this graph went up by 7. That's what a vertical shift looked like. And then remember, if I graphed, x minus 2 squared, that was a shift of 2 to the right. Okay, remember the horizontal shifts, the pluses and minuses, were opposite what you normally thought. So we did that in the parent functions. Same thing applies to our polynomials, okay? So let's look, for example, at some polynomials. So let's look at f of x is x to the fourth plus 8x. And then g of x is x to the fourth plus 8x minus 15, okay? Well, is it reflected about the x-axis? To be reflected, I would have to have a negative in front of everything, and so it was not reflected. Did it move horizontally? Well, if it moved horizontally instead of x to the fourth, I would see x minus 2 to the fourth or x plus 2 to the fourth. So there is a 0 shift horizontally. It looks like the only thing that happened to this graph is it was moved down by 15. Okay, so that's the translation that takes us from x to the fourth plus 8 to x to the fourth plus 8 minus 15. Okay, now let's look at the next one. What is the transformation that takes us from x to the fourth to minus x plus 13 to the fourth? So reflection about the x-axis, yes, that negative sign in front tells me this has been reflected. Did it move horizontally? Yes, it moved horizontally, and then that plus 13 means it moved to the left by 13, okay? Did it move vertically? The shift of vertically was 0, okay? If it moved vertically, I would see something like this. That would be moving it up 5, but I don't see that. So there's no vertical shift on this function, okay? Let's keep on going. Let's look at it. What if it appeared in factored form? So here you have f of x, x minus 4 times x minus 3, g of x minus x minus 4, x minus 3 plus 1. So this negative sign, that tells me that yes, there's a reflection about the axis. And then to look and see if there's a horizontal shift. Well, I've got x minus 4, x minus 3, x minus 4, x minus 3. Neither of those change. So there's 0 horizontal shift. But I do see this plus 1 on the end. So that means this graph moved upward by 1. Okay? So this is not really new. I mean, this is what you saw when we did the parent functions. It's just now instead of a parent function, you're given a polynomial and you're trying to figure out what the change is. Let's look at the next one. F of x is x to the 6. G of x is minus x to the 6 plus 7. So this indicates there was a reflection about the x-axis because of the negative sign. Horizontal shift, no. Horizontal shift, I would have had to have x plus 2 to the 6 or x minus 2 to the 6. Nothing happened horizontally, but this was moved up by 7 with a vertical shift. Let's look at the next one. So I'm in factored form. So I've got f of x is x minus 6, x plus 1. G of x is x minus 5, negative x minus 5, x plus 2, plus 1. Okay, so reflection about the axis, it looks like I can say yes to that. Vertical shift, it looks like there's a shift up by 1. Okay, and now I just need to figure out, was there a horizontal shift? Okay, so it looks like x minus 6 turned into x minus 5. And it looks like x plus 1 turned into x plus 2, okay? What could account for that happening? Well, if I were to add 1 to this left term, then that looks like that's how I got there. If I were to add 1 here, that looks like how I got to this term. So when I add 1, what does that mean? That is a horizontal shift of 1, but in which direction? That is a shift to the left. Okay, so remember, on the horizontal axis, if I add 1, I'm shifting to the left. If I subtracted 1, that would be shifting to the right. Okay? Those are probably a little bit harder to see, but we'll do a couple more of those, and then we'll look at some graphs. So let's look at this one. F of x to g of x. I can look right off the bat and say there's no reflection about the x-axis. I don't see a change of sign. And I can look and see that there's no vertical shift, okay? I've just got to figure out what the horizontal shift is. So it looks like x turned into x plus 5, x plus 4 became x plus 9, and x minus 6 became x minus 1. So what happened in each of those cases? It looks like plus 5, plus 5, plus 5, okay? Now, what if it would happen if I say plus 5, plus 5, plus 4? Then that would just be a whole different function. That's not a transformation. That's just a new equation. But because these things all did a plus 5, that means there was a horizontal shift, and plus 5 means it went to the left, okay? So it shifted left by 5 units, okay? Let's look at the next one. So if I can look at this immediately, I know there was a reflection about the x-axis. I know that it went up by 8, and I just have to determine the horizontal shift. So it looks like x plus 4, x minus 6, those all stayed the same. There is no horizontal shift in that case. And then the next one, there is a reflection, and it went up by 17. And the horizontal shift, it looks like the x became an x minus 3, okay? So I subtracted 3. The x plus 4 became an x plus 1. Still, that looks like a subtraction of 3. X minus 6 became x minus 9. Again, that's a subtraction of 3. This is a shift of 3 to the right, okay? So again, this should be an easier concept because you've seen it in the parent functions, so you should get it sort of right away. Let's continue on, and the next skill would be looking at a graph. So now what I'm asking you to tell me is look at the graph on the left, which is in red, and look at the graph on the right, which is in blue, and tell me what transformation happened to get me from the left graph to the right graph, okay? So what you want to do with this is, easiest thing is to pick out a point on this graph that you know. I know this is at the point that is 1, 0, okay? Where did that thing end up in the new graph? So it looks like that ended up right here. So that's what happened in the transformation. So in this transformation, this particular point moved over to where I see. So I got to figure out what got me there. Okay, so that means that this is what this moved to negative 4, 2. Okay, so this point moved to negative 4, 2. What would be the transformation that makes that happen? Now, first of all, you can tell that this is flipped. Okay, so if you look at the red graph, it goes up and down, and then the blue graph starts down and then up. So I know it's reflected about the x-axis. But what I can tell is that this particular point, 1, 0, somehow ended up at negative 4, 2. So negative 4, 2. It ended up right there on the graph at negative 4, 2. So what gets me there? I have to go 1, 2, 3, 4, 5, 5 to the left, and I have to go up 2, okay? So 5 to the left, so if you look at that, horizontal shift 5 to the left and up by 2. So to get from the red graph to the blue graph, like I said, first of all, pick a point and then tell what happens to that point. Now we could just sort of redo this. Let me just say, let's pick another point. But you want to pick a point that you actually know on the graph precisely where it is. So if I were to pick, say, this point right here, this point right here, I don't exactly know where that point is. I know it's between -3 and -2. That's not a good point for me to pick. Let's just say, for example, suppose I pick this point. That's -2, 0. Okay, to find where that moved to in the other graph. So if it looks like that one is a little bit harder for me to tell where it moved because it wasn't on a max or min, okay? So I got to figure out, okay, I'm not sure exactly where that moved somewhere in this area. So again, that's not a good point. The best points to pick would be relative max or mins, okay? Or if you look at zeros, where those hit as well. So again, you could have picked, say, this point, these 2 points, right here, -2, -3. Again, probably not the best points, but I think those correspond to here. So really your best point when you're picking this is to pick a max or min. So in this case, if you look at it, the best one we could have picked was this point right here, because it's easy to identify graphically where the corresponding point is for that. Even though you don't know what this point is, you could tell that it moved to here, so you could look at it and say, okay, if this is where it was, then it was between 2 and 3, and it moved it between 7 and 8. So that's going to be 5 spaces to the left, and then you look at which way it moved down as well. Okay.